Okay, let's go ahead and look at this question and start answering it together. So what we want to look at is we have two events. We are looking at high schoolers and if they pull the paper over the roll for toilet paper. So basically when you pull the roll, the toilet paper comes over the top instead of the backside. And then if they replace the toilet paper roll after it's empty. So what we want to do first is get our totals for each column. That sometimes will help. So if I look at each of my columns and rows and get my totals, there would be 70 people here. There would be 46 people here, which is a grand total of 116. And if I add up my rows, I'm going to have what is 82 in the first row and then 34 in the second row, which also adds to 116. So I've got all my totals. So now what we want to look at is we have two events. Either you replace the roll or you don't, and then you pull it over or you don't. So we want to explain in plain language what this notation means. So O with a little C on it. So the little C means complement, so opposite of. So if event O is pulling the toilet paper roll over, then event OC, or the complement of that, is that you don't pull it over. So this is the probability that you do not pull the toilet paper roll over. So to find that probability, we just got to find the amount of people that do not pull the toilet paper roll over. So if we look at our events, here is the column for, we're doing columns here for if you pull the roll over, and no, we want somebody that doesn't. So there are 46 people that don't pull the toilet paper roll over out of 116 people total in my table. So that's problem A. For problem B, this is notation. So it says the probability of selecting someone that is O or R. So O means you pull the toilet paper roll over, or R is that you replace it. So what's the chance we get somebody that either pulls it over or replaces the roll? And explain why we can't. It's my bird clock. Explain why. Nuthatch. Anyone's wondering. Okay, so explain why we can't just straight up add these together. So because usually when we do or, it's like I add up these people or these people and I get everybody together. But in this case, this is asking us why we can't do that, which means they're basically asking us, are these events mutually exclusive or are they not? So I can definitely be a person that pulls my toilet paper roll over, and I can be a person that replaces it also. So these are not mutually exclusive events. You can pull your toilet paper over and replace the roll. So let's actually find the probability then. So I have to be careful because there's going to be some people, since this is not mutually exclusive, there's going to be some people that fit into both categories. So what I want to do first is find all of my people that replace the toilet paper roll. So that would be these people. And then I also want to find all of the people that pull the roll over. So that would be these people. So if you notice, I've circled the 58 twice. So those are my people. I don't want to double count anyone. So when I find this probability of O or R, I have to be careful and make sure I don't double count those 58. So you can think of it this way. You can say, all right, well, I've got 58 out of 116 that do both. And then I have 12 out of the 116 that do just the pulling the roll over. And then I also have an additional 24 here that still replace the roll. So adding all those up will get us our final probability of people out of 116 that do both, and we haven't double counted anything.